need to bring our graphing skills together in detail with the most important topic so far, supply and demand. So what we're going to do here is graph a supply and a demand curve, and then we're going to walk around inside the graph a little bit to really make sure we understand what the points mean. It's not an art class. We're not just painting pretty pictures. It's not a math class. We're not just solving for X and Y. It's an economics class. It's applied math, and we have to be able to really think about what every point in the graph might mean. So that's what we're going to try to do today. Now make absolutely sure that if I give you a line, you can write down the equation for that line. And if I give you an equation, you can graph that line. So if you need to pause the video here to make sure that you can do that, I really encourage you to pause for just a minute to make sure you can. So our equations today, y equals 18 minus 2x. Which of those is the y-intercept? The 18, the number by itself. What's the slope? Minus 2. Now, I tell you that's the demand equation, but what if I didn't? How would you know that's the demand equation? You know because of the negative sign. Demand slopes downward, supply slopes upward. So we could write it in the standard way for the equation of a line. I strongly prefer to write p's and q's instead of y's and x's. Now here I have a little d subscript on q to make it explicit that this is quantity demanded. Sometimes I'll do that, sometimes I won't. And here's our supply equation, similarly with an S. So again, pause the video, make sure you can graph these very quickly and easily. So we start off here at the y-intercept of 18. First, let's label our axes. And we're starting off here at our y-intercept of 18, which means that if people are buying a quantity of 0, the price must be 18 or anything higher. Over 1, down 2, over 1, down 2, and if we keep doing that, we're going to end up down here at a quantity of 9, our x-intercept. If the price is 0, the quantity will be 9 units. So again, to double check, that slope of minus 2 says that rise over run between any 2 points. If we just look at the first and the last point there, the y-intercept and the x-intercept, the rise is minus 18 and the run is 9. The ratio there, minus 18 over 9, is minus 2. Now if we graph the supply equation, the y-intercept is 3 and the slope is 1. So we just want to go up 1 over 1, up 1 over 1, up 1 over 1, etc. So let's label our supply, let's label our demand, and let's start answering some of these questions down here to make sure we really understand what's going on. So remember that demand tells us the willingness and ability of people to buy different amounts, quantities, at each possible price. So at a price of 12, they want to buy 4, for example. The supply curve tells us about the willingness and ability of producers to supply this at each price they might think they can sell it for in the market. Alright, so down here it says, if the quantity demanded was 3, what's the price in the demand equation? If the quantity supplied was 3, what's the price in the supply equation? And tells us to draw a vertical line at q equals 3. So let's just go ahead and do that here. We do that in pink here. So if q equals 3, first let's look at the demand equation, the downward sloping line. And if we go down to where q equals 3, we see that the price over here on the left is $12. So that's our answer, $12. But if quantity equals 3, what is it that must be going on with the suppliers? Well, if we look at the supply curve here, and we see where quantity equals 3, then we look over here at the price, and they must be thinking that the price is $6, right? So that's our answer for that one. Now the next question says, what is the distance on the price axis between the demand and the supply curves? So what we're saying here is if we zoom in and we look at that point here and we look at that point down there, what is the distance between those 2 points there? That little line segment. Well, I'm just asking, well, if on the demand curve it says it's $12 and on the supply curve it says $6, what's the difference between those two prices? $6, right? 12 minus 6. We could count it. 1, 2, 3, 4, 5, 6. Now, strange as what we're doing might sound, this is actually a very important thing that we're going to do quite a bit in economics class, is really think about 2 points and what is the difference between them? How could we describe it? Now, why might we think about something like this? Remember, equilibrium is when we find a price where there's balance. Equilibrium means balance. Balance between the quantity people want to buy and the quantity people want to sell. We're not at equilibrium. For some reason, we're only selling 3 units instead of 5, which looks like the equilibrium quantity. Now, one reason we might be stuck here at a quantity of 3 is sometimes the government will pass a law called a production quota. Now, sometimes there's a similar kind of thing called an import quota, where the government passes a law saying we're only allowed to import a certain amount of a product. So in this case, what might be happening is the government said, hey, we're not going to allow you to produce 5 units, that equilibrium quantity. We want you to only be able to produce 3. Maybe this product is polluting, maybe it's bad for people, so they reduce the quantity we're allowed to produce. So in this case, what we might see is that even though for that quantity of 3 there, consumers might be willing to pay a price of $12, businesses would be willing to sell those 3 for a minimum of 6. Now, in practice, what we usually see when there's a quota is that the price goes up. Anytime something gets more scarce, more limited, normally we see the price for that kind of product go up in the market. So even though businesses would be willing to sell these 3 for a minimum price of $6, what we usually see is that the consumers end up having to pay more. 12. So that difference between the 12 consumers are willing to pay and the 6 the businesses would be willing to accept is the difference of $6 that we highlighted there in yellow. All right, let's think about a different weird kind of situation using our lines that we graphed. Suppose the price was $14. What would the quantity demanded be? And what would the quantity supplied be? Draw a horizontal line at the price of 14. What's the difference between the quantity demanded and the quantity supplied? All right, well, let's investigate that here. So at a price of 14, let's just draw a horizontal green line here and label it. So suppose the price, for whatever reason today, was $14. Let's look and see what the demanders would be thinking. Well, the demanders, if they see that price of 14, they're only going to want to buy 2 units down here, right? Now, what about the suppliers? What if the price was 14? Well, the supply curve at a price of $14, if we look at that price of 14, that says that suppliers would be willing to sell 11 at a price of $14. So let's picture market day. The suppliers show up, the buyers show up. They put the price tag of $14 out, and the suppliers are trying to sell 11 units, and the buyers over here are only wanting to buy 2. So the quantity demanded is 2. The quantity supplied is 11. What do we call the difference between when people are trying to sell 11 and they only sell 2? We call that a surplus. How big of a surplus would it be? Well, the difference there is the 11 minus 2 equals 9. Now, is that $9 or 9 what? Well, it would be 9 units of this product. Maybe it's basketballs, maybe it's shoes, maybe it's hot dogs. But at a price of $14, they're going to have 9 more that they brought to sell than they will actually sell. And again, we could count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9 units. And what we call that is a surplus, when you have a lot left over. Now, what about at a price of $5? What would the quantity demanded be? What would the quantity supplied be? Draw a horizontal line, and let's talk about it. So, price of 5. So, at a price of $5, let's see. The quantity demanded, the demand curve where it hits $5, looks like it's going to be between 6 and 7 units is how much people would want to buy. So it looks like 6.5. Now, how could we verify that it really is 6.5 and we're not just guessing here? Well, what we could do is we could plug in to our demand equation, right? So our demand equation up here is 18 minus 2Q. So price equals 18 minus 2Q. And if we plug in $5 for the price there, let's solve that for Q. Let's see, we could subtract 18 from both sides. We'd end up with minus 13 equals minus 2Q. We can multiply both sides by minus 1, divide both sides by 2, and those will cancel, and we're going to get Q equals 13 over 2, or 6.5. So it is as it seems here, 6.5 units. So people would want to buy 6.5 units. Now at a price of 5, how many would the businesses be wanting to sell? Not very many. Remember, law of supply. As the price gets higher, they're willing to supply more, willing to produce more. As the price goes lower, businesses are willing to produce less. So only 2. What's the difference between those two? 6.5 minus 2 would be 4.5 units. And what do we call that when people are trying to buy more than there is? Yeah, we would call that a shortage. So there's going to be a shortage of 4.5 units where people are trying to buy more than there is at that low price of $5. Now, why might we be at this price of $14 or this price of $5? Sometimes the governments like to pass laws to try to feel like they're in control, and they feel like they can overrule the laws of supply and demand. It doesn't work out too well usually, and at this price of $14 here, what the government could have done, and they've done it in the past, and I'm sure they'll do it in the future, is perhaps they passed what we call a price floor. A price floor, just like if you stand on the floor holds you up. A price floor raises the minimum price that's allowed by law. If you try to sell this good for less than $14, they could put you in jail, or they could issue fines against you, shut your business down. The United States government has put price floors on things like milk. One reason they gave for doing this is to try to help dairy farmers, to try to make sure that the price doesn't go too low so that dairy farmers don't go out of business. And so for many years in the United States, we had a price floor on milk. And if we have a price floor on milk, what is going to happen? The dairy producers are going to try to produce more milk than people want to buy, and we end up with a surplus, a lot of leftover milk. And if we have a lot of leftover milk that nobody wants to buy, it'll go bad, right? Unless you do something to it. Like you could convert it into cheese or butter or dry milk powder. And for anybody out here wondering where government cheese comes from, if you've ever heard about government cheese, it's true. It's not just a rumor. Government cheese comes from all this surplus milk that we used to have because of the price floor on milk. Now, the opposite kind of case, what if the government wants to lower a price to try to help people, I guess, but it usually doesn't work out very well. If we try to lower the price of something below the equilibrium price, it causes a shortage where people want to buy more with the low price, but producers are going to supply less, and so we're going to have a shortage. We call this kind of law a price ceiling, a legal maximum price for a product. So well-meaning, well-intentioned governments do these kinds of things, but again, they usually end up causing many more problems than if they had done nothing. Sometimes governments like to feel like they're doing something to help. Whether it helps or not isn't as important, right? Okay, problem number 5. Look at the graph. What is the equilibrium, price and quantity, approximately? Now I say approximately because until we verify it mathematically, we don't really know that that's the answer. We can just say that it looks like it's the answer. So here, this equilibrium looks like it's at a price of $8 and a quantity of 5 units. So equilibrium price of $8, quantity of 5 units. Let's write that down. Now let's verify that those really are the equilibrium price and quantity by solving these two equations simultaneously. Now in economics, this is a very easy thing to do, the way we set the problems up. We just take our supply equation and our demand equation. So we have P equals 18 minus 2Q. And we have also P equals 3 plus Q. That's our supply equation. And when you solve equations, there's a lot of ways to do this, but in economics, as I said, it's pretty easy. Since both of these are equal to P, what we can do is just say, well, since that equals P, we can just substitute that in there for P. In other words, we're setting the two equations equal to each other. So but if we do that, we can just say, here we have 18 minus 2Q equals 3 plus Q. Collect the constant parts, collect the Q parts, and see what we get. Take a minute and do that. Okay, now there's a lot of different ways we could go about doing it, but what I would do is add 2Q to both sides, and then subtract 3. So those cancel, subtract 3, and those cancel. And so we would end up with 18 minus 3 is 15 equals Q plus 2Q. Well, that'd be 3Qs. And here we divide both sides by 3, and sure enough, we get the Q equals 5, just like we thought it looked like on the graph. And then, how do we figure out what the equilibrium price is? We plug that Q equals 5 back into either of the two original equations. And the easiest one was probably be that supply curve, right? So we have P equals 3 plus Q, but if Q equals 5, we get $8. But you could plug it into either equation, should get the same answer. So again, we're just verifying. Sometimes you'll have two equations, and all the time in the real world, if you have supply and demand equations, they're never going to intersect exactly at whole numbers. Most of our practice problems in this class will. Problem number 7. What's the total revenue collected by sellers of this product? In other words, how much would people be spending if somebody went to the store and they needed to buy 5 things that each cost $8? Total revenue, how much money does the business put in the cash register, or total expenditure from the consumer side? Well, total revenue, anytime you see that phrase, total revenue, is always just price times quantity. Again, don't overthink this. It's just how much money do you spend if you buy 5 units at $8 a piece. So 5 times 8, $40, right? Now, one thing I want to show you that we'll see in the next chapter is often we want to be able to represent things as areas in this class. So let me show you what I mean. Total revenue here, let me clean up some of these lines. If we just draw a rectangle, so here we go, this golden rectangle represents total revenue. Why? Well, what's the area of a rectangle? Base times height, length times width. In other words, it's 5, quantity times height, price, right? Price times quantity. Now, a lot of times in this class, and this is going to become very important, as I said in the next chapter, when we add up areas, quite often we're adding up very important things in a graph. In this case, you can think about this area as adding up the $8 for the first unit, plus the $8 for the second unit, plus the third, plus the fourth, plus the fifth, right? $8 plus 8 plus 8 plus 8 plus 8 is 5 times 8. So this area adds up all these dollars that are being spent for this product, $8 a piece times 5 units. Okay, last question here. Suppose the supply changed to P equals 5 plus Q. Let's graph that. And is that going to be an increase or decrease in supply? What could have caused it? And how would this affect the equilibrium, price, quantity, and total revenue? Okay, let's clean this graph up a little bit again. So new supply curve, 5 plus Q. So the y-intercept is 5. And the slope is still up 1 over 1, up 1 over 1, up 1 over 1. All right, so here's our new supply curve. So what happens to the equilibrium price here? Looks like it goes up, right? So we're moving from point A to point B. And the equilibrium quantity is going to go down. And how would we describe this change in supply? It's moving to the left, right? So when a supply curve moves to the left, is that an increase in supply or a decrease in supply? All right, it's a decrease in supply. When you move to the left towards smaller quantities, that's a decrease in supply. Same thing for demand, by the way. If it moves left, it's a decrease in demand. Now think about our list of things that could cause a decrease in supply, and let's think about some examples. So what are some of those things that could decrease supply? Well, if all of a sudden we had worse technology to produce things, maybe one of our robots breaks down. Maybe if there are fewer producers in an industry, that would decrease the supply of a product. Maybe one producer goes out of business. What if the cost of our inputs, some of our labor, our land, our capital increases, making it more expensive to produce? Then that's going to decrease the supply curve. So make sure you have that list of ideas in your head where you can very easily access what are the things that could reduce the willingness and ability of suppliers to produce. Now that point B, at least the way I've drawn it, it doesn't look like it's on a whole number. So let's see what that new price and quantity are actually going to be. So our two equations, we have our old demand, 18 minus 2Q, and we want to set that equal to the new supply curve, 5 plus Q. So let's solve that for Q to see what we get. In the graph, it looks like it's around 4, maybe a little bit bigger. So again, let's subtract 5 from both sides. 18 minus 5 is 13. And then let's add 2Q to both sides, equals 3Q. So we're going to have 13 over 3 as our quantity. It's going to be 4 1/3, right? So Q equals 4.33333333. And then what price would that be? We plug that Q back into either of these two equations. That's probably the easiest one. And then our price is going to be equal to 5 plus 4.33, or 9.33, $9.33. Let's see if that looks right on our graph. Right, $9.33, 4.33 units. So price goes up, quantity goes down, and what happens to total revenue here? It could go up or it could go down. Well, price times quantity, 4.33 times 9.33. What do you get? I'm getting about $40.40 if we round it off to the nearest penny. So the total revenue is going to go up slightly. Again, it could go up or it could go down because we have two opposing forces here. Even though the price went up, we're selling less. So what happens to total revenue is actually going to be a mystery until we actually calculate it. So go back through. We just did a lot of simple, but a lot of analysis. Make sure you can go back through and think about what all this means and make sure that you could explain it to someone else. As always, if you have any questions, let me know. Otherwise, good luck with your studies, everybody.